Alright, cool. Let's jump into the technical part. This, again, is not a super deep dive, but it highlights how it works more from a developer perspective and what you have to do to build your own apps. Let's start with the basics. So at the core of all of this is the Tendermint consensus engine, which I've mentioned before is a proof-of-stake consensus algorithm that guarantees safety and liveness, and at the same time is optimally Byzantine fault tolerant and fork accountable, which is probably one of the more interesting things, because with most proof-of-stake implementations, you can't actually, if there's a fork happening, you can't actually tell who caused this fork. So it's very hard to slash people once the fork has happened. With Tendermint, you are fully aware of who caused the fork, and hence we can slash them accordingly. This is at the basic of the staking implementation, that if someone misbehaves, we can see who misbehaved, and we can punish them accordingly. Oh, and well, this is also kind of important for software engineering. Tendermint itself is super simple. It is like 25,000 lines of Go, and that includes the peer-to-peer part and the consensus part. If you're really interested and want to see if this actually works, like we say it works, it takes like 2 weeks to read the code base and figure out whether we did anything wrong. When you look at a lot of the other proof-of-stake implementations, they are much more complicated, usually not well specified, and usually mixed together with a lot of the application layer. So it makes it much harder from a developer perspective to actually verify that they do what they say they do. And this, of course, is also important if you're a company that wants to build like some enterprise application that hooks into the Cosmos Hub. Because you can literally hire 2 engineers and figure out whether the thing you're building on is safe. And I've mentioned Byzantine fault tolerance. And the only really important thing here to remember is that with Byzantine fault tolerant, you can have malicious actors in the system. So you can have people that are actively trying to disrupt your consensus, and as long as it's not more than 1/3, it causes absolutely no problems. Yeah, so why is Tendermint built as proof of stake? Or how is Tendermint actually built with proof of stake? Tendermint uses security deposits instead of wasting electricity. When you look at where the security in Bitcoin comes from, it's from the fact that you can't actively mine on 2 forks. You have to make an economic decision on where to invest your mining power, and you have to pick 1 fork to mine on, right? You can't mine on 2 forks at the same time without halving your hashing power. With proof of stake, the problem is actually that it is extremely cheap to produce blocks, which also makes it extremely efficient. So we don't have to waste massive amounts of electricity to secure the network. But this comes with the problem that right now I could support like 10,000 different forks on my laptop because it's literally like 1 signature. The way we combat this in proof of stake is by saying you have to put a security deposit down. And if you sign 2 blocks at the same height, you lose the security deposit. So at that stage, there's now an economic choice to be made for you. It is not economically feasible for you anymore to run the consensus on multiple forks at the same time, but rather, the same as in proof of work, you now have to pick which fork you want to work on, or which chain you want to work on. Moreover, Tendermint consensus is, as far as we can know, it is secure, and we're currently getting that formally verified by the same kind of guys that do a lot of the distributed database testing. So think about like MongoDB testing. They're running test suites against us right now. They've discovered, I think, a tiny liveness bug, which we fixed by now, but they haven't managed to violate safety yet, which is kind of good for us. And again, there's a full specification on GitHub of how this algorithm actually works, how a proof of stake implementation works. If you're really interested, you can just look at the specification and build it yourself. A lot of the other proof of stake algorithms that are out there are documented in random blog posts, and no one can really tell how they work, which is why it's very hard to actually fully understand if they're secure. And as far as I know, Tendermint is one of the only ones. It's the only one where it's very clear how the algorithm actually works, and it's very well documented how the algorithm works. Yes, so security through staking. As I mentioned before, in Bitcoin you have mining powers, you have to have an economic choice on which fork you're going on. In Tendermint we're using staking. As such, there is a token called the atom. And this atom is used very much like mining equipment. You can think about an atom like a 1 GPU unit, where you use this 1 GPU to secure the network. And as such, atoms aren't meant as a medium of exchange. They're not like ether. They're not a medium of exchange or a store of value. They're really mining equipment. And you have to have this mining equipment to secure the chain and nothing else. And then there's this concept of validators. So within the Cosmos Hub, there will be 100 validators. And these validators are tasked with securing the chain. In an ideal world, you would have as many validators as would want to participate in the consensus. However, this introduces a massive amount of network overhead, since you suddenly need to connect to all the different validators and involve them in the consensus process, which is related to another feature of Tendermint, which I'll talk about in a second. So we have 100 validators for the Cosmos Hub that have to put up a security deposit and then contribute to the consensus and the security of the network. And you could say this is more centralized than most other things. It's not as egalitarian as, for example, proof of work with Bitcoin or Ethereum. In reality, this is probably actually more decentralized, because with Bitcoin, I think the 4 biggest mining pools control like 50% of the network. So even if you only have 100, this is still far more decentralized than actually Bitcoin. And the important thing is, you don't need to be one of the hundreds. You don't need to be one of the 100 biggest atom holders to participate to become a validator. Because other people, let's say you want to run a validator, the rest of us can delegate our atoms to you, so we can delegate our mining equipment towards you. So you can still become a validator even though you only might have 1 atom. So validators are very much like big mining pools that don't waste electricity. Yes. With Tendermint, we also have 2 more really cool properties. One of them is that we can have very efficient light clients. When you want to build a light client on top of, let's say, proof of work chains like Bitcoin, the problem is you have to keep up with constantly with the headers. So your light client needs to be constantly connected to the network, needs to be constantly processing headers, which, if you, for example, want to run it on a phone, is a real problem because it wastes battery and it wastes your data plan. With Tendermint, since we have this concept of the validators, as long as the light client keeps track of the changes in the validator set, so the people that are validators, which should happen roughly once every 30 days, the light client only has to connect once every 30 days. And if they receive a block within that time, they can just look at the block and be fully certain that it's a valid block, because they can check whether it was signed by more than 2/3 of the validator set that they know about. And if that's the case, it's a fully secure block that was included in the chain. Oh, right, and the other cool thing is we have immediate finality. So within 1 block, you know whether your transaction was included. With Bitcoin, the problem is that, or with Ethereum as well, that from an application perspective, it's very hard to build on top, because you always have to take into account that you might not be on the longest chain after all. So you always have to deal with the fact that maybe after 6 transactions, you have a rollback where you didn't end up on the longest chain. With Tendermint, since we agree on the transactions before we produce the block, we know that these transactions will be in the final block. So after about 1 second, once the next block is mined, or once the next block is validated, you are certain that your transaction has been concluded. It is very much more like a normal response and request model where if the network tells me that this has gone through, it has gone through. So from an application perspective, it's much easier to build on top. Okay, so this is now actually the magical part where I'll tell you how this abstraction works, that the application logic can be completely removed from the consensus and peer-to-peer layer. And I will walk you through a basic example. I'll walk you through what actually happened when I ran the counter demo. When I ran the counter demo, what happened was that I submitted a transaction on the client side. So I submitted a 0. And then this yellow thing is Tendermint, the Tendermint consensus engine, by the way. And this green thing is the application logic. So what happened when we submitted the 0 was that it goes into something called the mempool. And this is where we store incoming transactions. Once Tendermint receives a transaction into the mempool, it makes a message call towards the application logic that is checkTX. And in checkTX, Tendermint sends the application the transaction it received, because Tendermint is fully agnostic to the transaction. To Tendermint, it's literally just bytes. Tendermint does not care what your transaction is. So it calls checkTX, and now the application logic has to go and say, is this a valid transaction? And in the case of the counter, it was, have I seen the 0 before? If yes, then this is not a valid transaction. Or is it not in order? So is it out of order? So is it 0, 1, 2, 4, for example? And in those two cases, it just rejects. It lets Tendermint know, no, this is not a valid transaction. And then Tendermint just throws away the transaction, right? It's not a valid transaction. The interesting part here is that, for example, in the case of Ethermint, this application, this checkTX logic is actually much more complicated. In Ethermint, what happens is the Ethermint application logic looks at the transaction and says, is it internally consistent? Does it have all the right fields? Does it decode correctly? Is it signed properly? Is the nonce correct for the account? Does it come from an existing account? Or does it come from an account that has money in it? Does the account that sent the transaction pay for transaction fees? Does the account have enough money for the value transferred on the transaction? So this checkTX is very much up to the application logic, and you can decide to do whatever verification, whatever checks you want to do on transaction, Tendermint gives you. Then the next step, the next major step, and by the way, so there are more than 2 message types. There isn't only checkTX and deliverTX. No, we call it, this is an old graphic, it's called deliverTX nowadays. There are, I think, roughly 10 or so message types, but they're all very similar, very well documented on how to implement them. And if you're writing in Go, it's already almost all the decoding is handled for you for these messages. So once we decide then to create a new block, the Tendermint core instance says, right, I'll take these 1,000 transactions or 100 transactions. It agrees with all the nodes in the network that these are the 100 transactions that should be included in the next block. And once they have reached agreement, each of the nodes in the network, each of the Tendermint instances, runs them against the application logic. And this is where actually the state change is happening. So now we have a transaction, the Tendermint core gives it to the application, and the application now has to update its state. So it has to update the database that's underlying the application. It does that 100 times, and the call finishes with a message called end block. On end block, the application's only job is to return one state root, one hash that represents the entire underlying database, so that this state root can be included in the next block in Tendermint. And here the determinism comes in, because if your application is not fully deterministic, they reach a different state here. And that means that the state root that you return is now different, and Tendermint will fail on this. Because this means that Tendermint can't actually accurately keep track of a state that your application should be in, which makes everything else not work. So determinism is very important. Oh, and yeah, this is called the Tendermint socket protocol. and this is the only part that your application has to implement. Yes. Do you have questions about this right now? Because I think the next part is about scalability and interoperability. Anyone? Questions? Do we have a second mic?
I want to ask the transparent for, I mean, when the validator to check, is there a process for computing the hash just for is there target or transparent for I can forecast who will generate the next block?
Oh right. No. You can't determine who will generate the next block.
So there is also a computing hash process.
Well, you can't. Let's say it like this: you can't predict who the next proposal will be far into the future. On like a block level, that might work, but it won't work for more than like 2 blocks. So you can't predict far into the future.
Thank you. Another question. Is it possible to transfer the message in the COM?
To change the message types?
Yes, a secure message.
What do you mean by secure message?
I mean, I can just transfer the COM, or I can also insert the secure message in the transaction.
I don't understand what you mean.
除了简单的进行币的交易，我们可不可以在币的交易中加入附加的信息，比如说安全的一些消息加入，或者彩色币之类的功能？
This question is really, in addition to coin transfer functionality, can you include extra semantics in the message, in the different types of messages?
So in the transaction, yes, right? So this transaction over here can be whatever. It doesn't matter. Like Tendermint does not care. As long as the application can handle that message, it can be any sort of arbitrary message type.
Okay. 所以这个 transaction 可以是 application specific， 因为它对于 Tendermint core 来说它是透明的。你只要你的 application logic 可以 interpret， 可以理解你的 transaction， 可以处理它就可以了。
Yeah.
So the application, let's say you have the application running 2 copies of it.
Yeah.
And you have an asset, like a piece of real estate, and 2 people at the exact same time, or near enough, within the same block. One of them decides to transfer it to this guy, and the other decides to transfer it to this guy. What's going to happen?
Yeah.
They're running on different apps. So how are you going to come to some sort of consensus to this? Obviously, your root hash thing is not going to match, etc.
So they will be running on the same application, right? They will be running on a separate instance of the application.
Yeah,
It's
2
this,
instances.
yeah.
In one instance it gets the message to do A, and the other give it to B.
Yeah. That would not happen because the transactions will have been determined before we actually run the state changes. So where's the kicker? So Tendermint core here determines the 100 transactions to run. So no 2 applications will receive different ordering of messages unless they're malicious or unless they have been targeted by a malicious actor. And if
So just to modify the question slightly. So let's say that your logic basically said, if the account value is greater than 100, then transfer to A and deduct 10. And if it's if it's less than it, transfer it to B. And so, there's this ordering logic then, and so we're at the value 105, and so from one perspective, we're supposed to do one thing, because it's greater than 100, and so now we have this kind of fork in the logic that bifurcates both based on the initial state, that we have a different set of final states that we're supposed to reach. And so within one block, we could have, depending on how you order the things in so how are you coming with the ordering? Like, if two people submit things independently, are you just doing it based on the clock or what?
No, so the ordering is determined by the consensus engine, right? So the consensus engine, Tendermint core, the consensus engine, decides on the ordering of transactions. And all applications run the same transactions in the same order. They're not so this step is the same in all applications, right? So there will not be a fork if the application itself is deterministic, because they would increase the account balance by 1, all of them would run that, and then deduct it by, let's say, 5, all of them would run that. So there's not the case that one application would see the -5 transaction first and then the +1. Any other questions? Questions?
This is a simple one. So what's the role of Atom, the Cosmos coin in this system?
Yeah, so the Cosmos coin is there to provide an economic incentive so that validators don't cheat. Because in Bitcoin you have the economic incentive being wasting electricity on the wrong thing. Here you need atoms to participate in the consensus, and if you cheat you lose your atoms. That's what atoms are really for. You can think of them like mining equipment for proof of stake.
So in other words, it's not like the gas. It's not the same mechanism of Ethereum.
No, it's not gas. We're currently speccing this out in terms of economics and we're releasing this in like a specific white paper for that as well. There will most likely be a different coin to pay for transaction fees. Right.
So which means there will be a mechanism.
Oh yeah, there's a mechanism to prevent spam.
Otherwise,
Yeah.
some people just doing this work.
No, yeah, there is a spam prevention mechanism, don't worry. We're not that well thought.
I just want to add one more thing. We don't have a Cosmos.
I don't have Cosmos logo.
Okay. So, all right. So one thing about Atom, right? Just want to add that. Look at our Cosmos logo. The O there has a 0 and then slash. Right. That's actually hold the meaning. And that's why we call our global hackathon Hack Atom, right? Because it is you hack the atom. So if you do something bad, your token, which is your atom, will get slash. That's part of the punishment. So I just want to make sure this is kind of clear. There's meaning on this logo. So anyway, go ahead.
Yeah, I'll check.
Now I have a question about but will there be any rewards for people who run validators? So
Yes, validators do earn transaction fees first of all, and they might earn yearly rewards for actually participating in the consensus. So you can see most likely a 5% increase in your atom holdings every year. So you are rewarded to become a validator. But again, we're currently speccing out the exact economics. So if you're interested in becoming a validator, you have to wait like 2 months before we release the entire economics behind this.
the final question. So those slashed atoms, where did they go?
They're burned. They just disappear. To keep it simple. Did we have other questions online? Well, so I think the last question. For blockchains not involving tokens at all, can I make a transaction or use the Cosmos network? Yes. Because tokens, in the end, are the only thing that tokens are really useful is spam prevention. And in case of Ethereum, also determinism. And if your application can handle terminating in some way and prevent spam in some way, so for example, you could use the native fee token in your application as well, then you don't have to have tokens inside your application, as long as you can guarantee that it terminates eventually. I'm guessing that was your question, by the way.
Yeah.
Oh, really? Okay. Good question, then. What's the process of validator selection? We're currently arguing about this as a team. It will be that we will have a phase in which you can't send tokens, and you can only stake atoms to other validators until we have a minimum threshold of validators. Let's say like we at least have 50 validators, at which point you will then be able to use the network. You can think of it very much like Ethereum started, where initially they didn't allow transactions until they were certain the network was stable. This is kind of the same thing, so we will have a process where I, as a tiny atom holder, for example, I don't want to run my own validator because it's a lot of work, it needs to be constantly online, it needs to be very secure. So I rather choose to delegate to you because you might be like a company like Red Hat that is very good at running network infrastructure. So you're running our validator, a bunch of us are delegating to you. This is happening around the world, so a bunch of people are delegating to different people, to different validators, and then the top 100 people with the most atoms delegated to them, so the biggest mining pools, essentially, we should call them validation pools. The biggest validation pools now validate the network. And as soon as the 101st validator passes the 100th validator, we switch validators. So it's a very dynamic process where the validator set could update every once in a while, because suddenly I don't trust you anymore, so I delegate to you, now you're in the top 100, and now you are validating. Yes, so how can you convince other people that you're actually trustworthy, they should delegate to you? You can cryptographically sign, for example, with a certificate that you got from a certificate authority, so that people know your real identity. You can somehow establish that you're a real person or that you have knowledge in running a validator. But that's very much up to you there could be people that run validators completely anonymous if there's enough people trusting them. And the next thing might be that you just might have to put up a lot of atoms initially so that people believe that you have skin in the game, right? Because if I only have one atom and everything is delegated to me and I'm fully anonymous, I might not care whether I get slashed and lose half of all my atoms, right? Because I only lost like half an atom. So initially, they might have to put up more atoms. Let's go back to the presentation. I have some things left. And after that we can run through all the remaining questions and any questions you might have. There. So scalability, how does it work actually that you can have multiple blockchains connecting through a central hub? That works through a protocol called the IBC, the Inter-Blockchain Communication Protocol. Should we get out of the way? And it's actually a very simple protocol. You have two message types, IBC block commit and IBC packet TX. IBC block commit TX and IBC packet TX. And it essentially allows you to update the latest block. So I'm running my own chain, so I'm now able to send the latest block header to the hub, and then that's the first message type, and the second message type is that I'm generating a proof that some sort of transaction has happened within my state, and I'm proving that to the Cosmos hub. And that's really all it is. And there was also a question about whether we'd be able to move something arbitrary state, so something besides tokens. That is kind of the holy grail, and we are actively researching into that topic. Currently, it's not possible, at least not in a secure way. So currently, we can only securely move tokens between different blockchains. But from a very simple perspective, it literally involves I send a coin to the hub, and then the hub sends the coin to the other. My zone sends a coin to the hub, and then from the hub I go to another zone. And it's a very simple protocol, and it's the only thing that people have to actually implement to be able to join the hub. Yeah, here you can also see this a little bit. So how the hubs work, right? So you have one central hub, we have multiple zones connected to it, they all connect over IBC to the hub, and they can all work like this. In a theoretical sense, they could also, let's say you have two zones that are very high traffic, so they do a lot of transactions between each other. Those two zones could choose to connect directly, but it is generally not advisable because the Cosmos Hub has actually the important functionality of maintaining this global invariance of how many of each atom, how many of each token are currently in the Cosmos Hub. Oh yeah, and the cool thing in terms of security for this, or in terms of, not security, but rather fault tolerance, is we can have more than one hub, and hubs can be competitive. Any one zone can become a hub, as long as everyone else chooses to do the transactions through that zone. In that sense, we can have very highly fault-tolerant systems that actually can handle network partitions. Let's say that Shanghai, for example, could have its own geographical hub, and then all the zones within Shanghai connect to this hub. Even if the rest of the world goes offline, it doesn't actually matter to Shanghai, because all transactions within Shanghai can still be processed. We just can't send money or receive money from the rest of the world. Now think about how this currently works in Bitcoin. If one mining pool goes offline, it takes like 20% of the mining power with it, suddenly we have a huge problem, even in the rest of the world. So somewhere in South America, we could suddenly have problems that we can't process transactions as fast anymore. With the Cosmos Hub, we can have this hierarchical structure of hubs, of regional hubs, down to the lowest level that make it possible that even if the rest of the system goes down due to some network fault, for example, you can still do transactions locally. And if you're into like local coins and keeping money within the local economy, this is also a really cool research topic for you on how you can build local coins that can't like leave your hub and have to be spent in the local economy. Zones. Yes, I talked about zones. Oh yeah, one last thing about zones is actually, you might wonder, can any zone create any arbitrary token? And the answer is no. So for one token, let's say for the pegged Ethereum, pegged Ether, there's only one source zone. And only that zone can create new tokens. The other zones can still move the token around. That's not a problem, but they just can't create additional tokens that goes over the balance that they have on the hub. That enforces a global invariant that we have to have the same amount of tokens across all zones, so that zones can't cheat. That's really it. Oh yeah, scalability. This is a fun one. So currently, Tendermint itself supports roughly 30,000 transactions a second. That's without an application though. Ethermint supports roughly 200. And again, so even just the raw speed, even if we just have one zone, we're just way faster than any comparable system. Of course, when you take into account that we can arbitrarily scale this horizontally, we could be at like 120,000 transactions easily as soon as we have 4 Tendermint instances running. Yeah, so zones can contain arbitrary business logic. If you're really fancying it, you can write your application logic in like Java 4 and use the most archaic technology possible. As long as it's deterministic, it still will work with the Cosmos Hub. Of course, you have to get users to use your application, so you might not want to run it in Java 4. Yep, they synchronize through the peer or the hub. Yep. Oh yeah, and I mentioned this earlier on, but I really want to stress this. If you're a company or if you're a startup and you don't want to open source your application logic, that's fine. As long as your users are willing to use you, you can still run it on the Cosmos Hub as a Cosmos app. We don't care like how your application logic works, because ultimately you are responsible for your application logic. So if something goes wrong with your application, people will maybe start suing you, or you lose your reputation, you lose your business. But this entire thing, that your application logic is completely up to you, and we don't care. Yeah, so I'll just give you a quick run through of the apps we're developing. So it's Ethermint. Ethermint is the EVM implementation on top of Cosmos. It's fully compatible with all the existing Ethereum tooling, or all the existing wallets. It works with like the Ledger-S, Web3, all the RPC calls are Web3, everything really, but at 20 times the speed. We have the Weave SDK. I talked about this earlier as well, cryptocurrency framework. We're building the hub with it. It's a very active project right now. Well, all of our projects are very active, but particularly this went through a lot of breaking changes in like the last 2 weeks since we were on a retreat. So the documentation currently is very much out of date since we fixed a lot, changed a lot of the code. So unless you really want to dive into the code, I might give it like a week to fix the documentation. And this basically allows you to build your own cryptocurrencies. If you wanted to build a cryptocurrency, let's say last year you had to worry about, you could use one of the big archaic C++ code bases, or you had to build everything from scratch. With Weave, it can be like maybe 300 lines, 400 lines, and you have your own cryptocurrency up and running. We are of course building the hub. Currently we're very much focusing on the security, so how do we do the slashing? What validators misbehave? How do we prove that validators misbehave? Oh, and when I'm saying we're currently building it, this is all fully specified, we're just implementing it. We're building the Ethereum Pack Zone. I talked about this earlier as well. Since this is one of the bigger projects that also involves like external things, this is quite not as straightforward as most people would think, but still very doable. So if you're now interested in like building your own things on top of the Cosmos Hub, there are, you have like 3 choices. So you can build on top of Ethermint, which is probably the easiest way if you want to get a quick prototype out there, because you can just use Solidity, and there are a lot of good guides on how to use Solidity to build your own cryptocurrencies. Or you can use one of our language SDKs. So we currently have the Tendermint socket protocol implemented in all these languages, and I think we've also added Haskell lately. But even if it's not implemented in your favorite language, it's probably like 200 lines of code to do it. It's really not a complicated protocol. So this is really the way to get started. I would heavily suggest, if you're a developer, I would go for like option 2, because it's probably the most powerful, because you have the most flexibility. But if you just want to get something quick and dirty up and running, just use Solidity. And just one idea on what kind of application you can build is you can build awesome banking apps which are not susceptible to man-in-the-middle attacks at all. Because the banking app can be a light client towards your application logic. And the light client itself can verify all the data it receives. It doesn't even need to run over a secure connection. This our blockchain is secure by design on a protocol level. We don't need certificate authorities to authenticate it. You have to trust one thing when you run this app. You have to trust the initial validator set. But as long as you trust the initial validator set, very much like you trust the initial Genesis block for Bitcoin or Ethereum, you're fully secure as long as you come online once in a while. Yeah, I think that's probably one of the most interesting apps you can build right now, because banks might pay you a shit ton of money to do that. Questions? Right, next steps. So I followed Jim's advice and put in a pun. You are on the brink of discovery, and I really hope that you took something away from this talk, and that you now have an idea on what you can use the Cosmos Hub for, and how you can build Cosmos apps. If you have questions about this, I'm still available later on, so please ask me. And this will really be the future of cryptocurrencies, because this is one of the only projects that tackles interoperability and scalability at the same time. So, as to the future roadmap we're taking this project, we should have production-ready testnets up in October, so where all the slashing logic is implemented, And if you want to run your own validator on the testnet, like join our Rocket Chat instance, start talking to us. We're slowly adding validators from the community to actually test for those, to find any bugs. And depending on how well this goes, we will have a live network towards the end of the year, where there's actually real value involved and you can have real uptime expectations and everything. So, how to learn more? We're currently working on making it way easier for people to start getting involved with Tendermint and Cosmos. So, we host developer chats every 2 weeks. So if you have questions, immediate questions, that's a good place to start. They're also recorded on YouTube, so you can watch them later on. We also have a YouTube channel. I might be working with our local partners to also get this up on the Chinese version of YouTube, because that might be way easier for you guys to access. Yeah. Plus we have blogs. We also work on translating them into Chinese. And these blogs explain a lot of the things around how do you build your first app, how you connect to the testnets. Oh yeah, by the way, we currently do have like 3 testnets up and running, but they're very early stage testnets. So if you're looking for like proper, you might want to run it locally instead. We also have mailing lists, so do join our mailing lists. And we do regular meetups. So I think Bianjay is going to run more meetups as well. So that's really the places where you can learn more. If you want to get in touch, we do have WeChat groups, we have Rocket Chat, over email or GitHub works as well. If you're a developer and you find issues, please post them to GitHub or let us know on Rocket Chat. Yeah, so upcoming events, we will have some meetups in Korea, we're going to have some more meetups here. There's a conference happening in the US, so if you're in the US, that's a good place. Hack is currently happening, right, so maybe today is even a good time to meet your team. And a lot of the team behind Cosmos will be at DEF CON 3 in Mexico. So if you're around there, come find us. I think we might be giving out like little gimmicks in the form of atoms. Yeah. So extra resource, by the way, I'll distribute these slides afterwards. So like, these are all links and you can find them. And oh yeah, and we're currently working also on educational series. So like how to build your first application, how to build your first Cosmos app, what are the basic steps you have to take care of there. And how to interact with the ecosystem. So that should be coming out sometime next month. So please look forward to that. And we'll also try to, of course, translate this into Chinese as well. Yeah, so thank you very much for listening to me. I hope you enjoyed this. Yeah. If you have questions, reach me over here. Those are my research interests if you want to talk to me about some random crap. Thank you very much. All right, and questions. Are there any questions right now from the audience? Okay, then I'll check. Is there something on WeChat that should tackle? For mobile banking, is the validator set changed? No, but the thing is, when the mobile client comes online for the first time, it's presented with an initial validator hash, which represents the initial validator set. So what you, from a user perspective, have to make sure is that the user has some out-of-band way to verify this validator hash, so that they know that they're actually talking to an honest client. Because all the future security lies in the fact that you know, like that you can identify the correct validator set. No, validators will not be able to validate physical assets, I think. It seems interesting though. For an Asian hub with Asian zones as Zone 1, how does the hub communicate to other hubs around the world? To another zone or another hub. So the way it works is that, let's say I'm Zone 1, I talk to the Asian hub, and then from the Asian hub you talk to the European hub, and from the European hub you then talk to the zone. So it's like a multi-hop process, where you go from like server to server to server until you reach your final destination. So if you want to develop the IBC implementation, that is currently within our Basecoin repo. We're also reading repos. Originally, Weave was called Basecoin. Sorry for the confusion. We're changing names. I won't have time to show you today, but IBC is implemented on top of Basecoin or Weave. So if you're interested, do check that out. Yeah, so the question is then IBC for Stellar, Ripple, Ethereum, or any other chain. That's really up to someone to build a peg zone, and then there will be. And by the way, you can run these peg zones yourself. You just have to create your own validator set or talk to the Cosmos Hub in terms of the government mechanism that Ash mentioned, so that the Cosmos validator set might be running some other peg zones as well, and then people running those pegs can earn transaction fees. So there is an economic incentive behind building extra peg zones. So actually the structure of the zones becomes a directed acyclic graph. I'm talking about the question like, currently hub zone structure is only one depth tree. It can be any arbitrary depth, but of course extra depth adds extra overhead. So it's probably not going to grow too deep. Is there total amount of Cosmos tokens? Jim, do you know the total amount?
Yeah,
yes, that is.
It's 16.8 million.
16.8 million. So yeah, the role of the Cosmos coin in the system is the security of the system. We talked about that before. Yeah, so we also talked about communication between hubs. In terms of performance, you can expect, it depends on the application logic. So if your application logic is very easy, you're going to a very high throughput there. If your application logic is very complicated, you're going to a lower throughput there. But again, you can just add zones.
Sorry, it's 168 million, sorry.
168 million, not 16 million. They aren't necessarily, they're not atomic swaps necessarily. Yes, so it is possible to extend it to IBC packets to arbitrary data. The problem becomes on how does the hub validate this arbitrary data without understanding the application logic that generated this data, right? So we're currently researching different ways of doing this, but it's still in very early stages and might not come out for like 2 or 3 years. We'll see. Hopefully there's a way, because that'd be really cool. Right, this also happened. All the Chinese questions I could read. I think we have covered them. Delegation. Should a zone undergo a 67% fork attack, and the hub has already synchronized both forks, how's the whole network going to handle the situation? If there's a 67% attack, it means that all bets are off, right? Because someone controls the entire network. It's like Bitcoin being controlled by 51%. In these cases, there's the governance mechanism kicks in. The governance mechanism also kicks in other times, but in these kind of extraordinary events, we also rely on out-of-band human consensus on what to do next. So if the entire network is under attack, or if the entire network broke because someone managed to get a 67% stake in the network, there will be human governance involved. And have we covered these questions? Okay. Any other last questions?
In fact, several questions. So first of all, so when you talk about the exchange of the asset here in the network, is there only tangible asset or intangible asset? From here we talk about token. How about cars, books, whatever thing?
Yeah, so if you can tokenize cars, we can exchange car tokens as well.
Following this question, so think about, just now you have a very important hypothesis that the asset itself will only need to be issued by a single role. That's a very important assumption, right? So singular is tangible asset, right? If it's an order, or if it's a car, right? I want to register the car for one row, but I can also copy this car. I mean, when I say copy, the same plate number, but different car maybe, and register that row in different row. How to do the transfer management across multiple row? That would be very challenging problem.
I think we're going to take this later on because I think it's a more involved question that I have to think about more.
That's a real question.
Yeah.
The answer is every zone could have its own governance. As a matter of fact, like if you look at initially we're going to launch with Ethereum supporting Bitcoin, right? That is itself its own governance, right? Which we're not controlling. So in the case that you're going to peg a goat into a real goat, actually, that's actually one of our interesting project, which is how do you actually create let's say, a real assets and then peg it to the network.
Fancy
Right.
word for that, by the way, digital
Right.
twin.
Yeah.
Oh,
Right.
fancy.
So,
Switch gears.
so let's say you're a farmer and you own a crops and you want to basically create a future trading commodities. You can technically build a micro exchange, right? A micro exchange, which is perfectly makes sense because it in blockchain, like in the traditional exchange, will be very expensive to build just to trade somewhere in Africa like a goat, right? But you can actually do this in Cosmos, and that zone will have its own governance. Obviously, you have to come up with some ways to punish. Let's say you have only 5 goats and you want to represent like 50 goats, right? That you will have its own governance and enforcement, which is manual. So that's why it makes sense for you to create a process, an out-of-band process to, let's say, tag every goat directly before you enter it into the blockchain. So you have a one-on-one sort of peg into that one asset into the one blockchain. It's always guaranteed entry. And you can actually include that in your blockchain. So every goat would have a, let's say, for example, one of those tracker, right? And that could be inserted into blockchain, and that would be sort of like a fly trap into an amber, like it's completely frozen in the blockchain. So you can't change that, right? So anyway, so that's one of your answers. Right?
Some more questions from the audience? Okay. Yeah, thank you very much all for coming. Harriet, do you have like last minute announcements?
Yeah, first of all, I want to thank all our great speakers coming all the way around the world, from UK, from Germany, from US, from Korea, come here to deliver this thorough technical dive. And I hope like today give everyone a good sense of what Cosmos is. And 刚才都忘了，他们一直在说英文，实际上我应该给大家讲中文来着。对，这样的，其实我是感觉就是今天呢，希望大家确实像大家刚才就是我们的这个演讲嘉宾所讲的一样，希望大家从当中能够学到一些东西。然后呢，我们现在站在创新的最前沿，非常希望大家加入我们。今天的活动呢马上就要结束，但是呢，其实今天是刚刚一个新的开始 ，Cosmos China 中国社区今天是开启的日子。然后大家可以有多种方式加入到我们当中来。其中最重要的一件事情是，如果你有兴趣加入跨链技术的开发的话呢，第一件事可以加入到这个 Hackathon， 今天正式开启，而且是为了庆祝中国社区的开放。然后第二件事情呢，刚才也提到了，像那个Agent 也谈到，我们有很多的一些技术的一些文档，如果大家要是有兴趣的话呢，也可以做志愿者，然后来帮助我们一块来翻译这些文档，让中国社区能够更好的接触到这样的技术。当然呢，我们也会有礼物可以发给大家，包括 Atom 啊，或者这一类的一些cryptocurrency。然后第三个呢，我们也希望呢有更多的一些程序员 developer 能够加入我们。我们很快也会要进行一些开发团队的一些招募，我们很有可能会在上海还有在杭州都会设立开发团队。如果有兴趣的，希望大家能够关注我们的公众号，然后能够加入到我们的这个 WeChat 的这一个 个社群里面来，积极的贡献你的一些想法，然后加入到这儿来一块儿进行开发，一块儿加入Hackathon， 我们大家一起来推进这个创新的权益。好，谢谢大家。茶歇那边还有些吃的，然后大家呢还可以呢在这儿就是吃些东西。